Alright guys, this is your favorite math geek, and I'm helping you with question 24 from section 3.1. Now, my general strategy, the way that I think about this, and there are several ways to solve this, is I think of that all that stuff on the top divided by xdn as being the same as 1 over xdn times whatever's in the bracket. Now, you can also distribute into the bracket, which means you can basically consider this to be 1 over xdn times a plus 1 over xdn times b plus 1 over xdn times c, and so on and so forth. And the other thing to remember is that you can write a square root as a polynomial. In this case, the square root of x is the same as x to the power of 1/2, but there's a more general formula for when you run into harder roots. Anyways, so let's start solving this problem. First of all, I recognize that I have that square root, and that because we're doing derivatives, it'd be much nicer if it said x to the 1/2. So I convert the square root to a polynomial raised to a power. Next step, I take that x squared on the bottom and I move it out, and I kind of treat it as a fraction. My next step is then I multiply both terms by the 1 over x squared. Now there's one more trick that you can use, which is when you're moving a power from the downstairs to the upstairs, you can basically just negate it. So in this case, that 1 over x squared is really the same as x to the power of -2. And now you're multiplying powers together, right? And when you multiply powers together, you add the powers. So this is the same as, the first term is the same as x to -2 plus 1/2. And the second term is the same as x to the power of -2 plus 1. That's nice and easy because -2 plus 1 is just -1. So that part's handled. With the first part, it's a little bit harder to add 2 to the power of 1/2 unless you convert that 2 into the terms of halves. So -2 is the same as -4/2, and you're adding a half. So if you add 1/2 to -4/2, you get -3/2 plus the stuff that you had before, x to the power of -1. Now that all that prep work is done, you can start doing the derivative. And you can take the derivative of each term separately, which makes it a little bit easier. Remember, when you're doing the derivative of a higher order polynomial, you take the old power and you move it in front. So in this case, we're moving -3 over 2 in front, and we're subtracting 1 from the power. And for the second term, we're moving -1 in the front, and we're subtracting 1 from the power. Now, of course, it's convenient to, once again, convert that 1 into halves. So subtracting 1 is the same as subtracting 2 over 2. When you have -3/2 and -2 over 2, you get -5 over 2. And you still have the old power in front, which is the -3/2. And for the second term, you just had -1 minus 1, which is, of course, -2. And you still have the old power in front of -1. And that's basically the solution. Now, normally when you write your final solution, you probably wouldn't include that -1 in front of the x squared because it's sort of redundant, but that's all that you need to do. So once again, this is similar to question 19 we did a little bit earlier, where they basically want you to figure out how to deal with a polynomial on the downstairs with a slightly complicated upstairs. And that's about it. All right. And so what they're trying to teach you is basic distribution and how to play around with your powers and remind you of all those algebra tricks that you might have forgotten since high school. And if you're still in high school, the ones that you might have forgotten since grade 10 or 11. Anyways, thank you for watching. If you have any more questions, that you need help with, feel free to send a screenshot to my email address and I'll try to solve them when I have time. I do plan to upload more videos from this textbook chapter, so if this was helpful, please consider liking and subscribing, and so you can watch more videos in the future as they become available. Thank you, and goodbye.